So in this video, we're going to be talking about something called the integral test. But before I get into that definition, let me just discuss something real quick. So when you have an infinite series that satisfies certain properties, we can use a continuous function with the very same formula as the series that we're trying to find the summation of to determine if it converges or if it diverges. All right, so there's some conditions that are going to be met, and we're going to talk about them right here in the definition. So let's take a look about and learn about the integral test. So it says, let a sub n be a sequence of positive terms. It says, suppose that a sub n equals f of n, where f is some continuous, positive, decreasing function of x for all x greater than or equal to n, where n is a positive integer. So here are the three conditions. All right, f has to be a continuous function, it must be positive, and it must be decreasing. All right, then we can say the series, which is the summation here from n to infinity of a sub n, and the integral from n to infinity of f of x dx both either converge or they both diverge. All right, so we're going to take a look at an example here, number 4. All right, and we're going to see how we can apply the integral test to determine the, in this case, convergence or divergence of 1 over 2n minus 1. So we're going to do a little bit of integration. It's not that bad. It's a pretty basic one here, but let's go ahead and take a look. So the first thing I'm going to do, I notice this is going from 1 to infinity, so I'm already thinking, okay, improper integral here. So let me just take this limit as n goes to infinity. All right, and I'm going to integrate in this case from 1 to little n. All right, 1 to n, and I'm going to take dx over, in this case, 2x minus 1. So that matches or mirrors the sequence, and this is that substitution that I was getting at, that you're going to say, suppose a sub n equals f of n. This is what we're talking about. All right, we're writing it as this function of x now. All right, so what we're going to do is we're going to integrate this. Now, the only way that I know how to really integrate this is by doing a basic u substitution. So I'm going to say u equals 2x minus 1 and du equals 2 dx. So I'm going to take care of everything that's missing in this case. So I'm missing a 2, I make it happen, but by consequence I need a 1/2 on the outside. All right, I'm not going to adjust my limits of integration, so while it may be mathematically incorrect, I'm just going to carry on those limits of integration just so I don't forget about them. All right, so let's see what this looks like. All right, let's see. I'm going to end up with, again, the limit as n goes to infinity. All right, I have 1/2 on the outside, and then this right here, let me just put my rings around this. This right here represents du, and this right here represents u. So this implies you know a little bit about u substitution here. All right, so we have basically the integral then of 1/2 of du over u. All right, a very basic integral. Now again, I'm loosely writing from 1 to n. Technically not correct, but we're just keeping it there so we don't forget about that. All right, well, this is a very basic integral now that we need to evaluate. This is the limit again as n goes to infinity, and du over u just becomes the natural log of the absolute value of u. All right, but we can't forget our 1/2 that goes right in the front. And this is evaluated again from 1 to n, but now we're ready to go back and make our substitution, and that is our u substitution, back substitute. So we have 1/2 the natural log of 2x minus 1, and again this one now can be evaluated from 1 to n. Now it's legal. All right, so let's figure out what happens. Well, when you have this 1 to n, you're going to end up with 2n minus 1, a natural log of that, and 1/2 as this is going on. And you plug in the 1, 2 minus 1 is 1, natural log of 1 is just 0, so we really don't need to plug in the 1. We plug in the 1, we get 0. So what happens then as n goes to infinity? So I want you to think very carefully about this, and you can verify. What's happening here is that we're getting increasingly larger. All right, so that means that the natural log is going to itself get increasingly larger. So what happens, so as n goes to infinity for this thing here, this 1/2 of the natural log of, in this case, 2n minus 1, all right, is going to be approaching infinity. Therefore, the conclusion that we make is that since it doesn't settle on a particular number, we can say that this one here diverges. And so we use what's called the integral test, all right? And again, the premise is that you find a function that mirrors the sequence, all right? You find this limit, you do the integration, and you can determine if it converges or diverges. And in this case, it diverged. So as always, I hope this video was helpful. And remember, like and subscribe.